Hello, good morning. Hey. So finally we come to last week. Okay. So, I'm going to record all your presentation today. So if you are going to use your computer to demo, please log in to the Google Meet. Okay, so you can share your desktop through the Google Meet. Okay, so you should be able to. 哎，这个不一样哦，靠，这不一样。没有，刚记录的啊，那改一下好了。Sorry, a mistake. So if you are going to use your computer, please log into the. Okay, so now it's correct. 镜头怎么怪怪的？不行。Sorry. So if you are going to use your computer, please join the meeting so you can share your desktop. Okay, so before we start, we need to decide which team go to present first. So that's lottery. So which team want to be the first? You want to be first? So you come here. So you any team want to be the first? You are number two first. And any volunteers? So number 5? And any others? Number 4. So we don't need to go lottery. And number 1. And how about the others? Number 6, number 3. Okay. So just follow these. 这镜头不太清楚。Okay, so if you make mistake in your demo, don't worry about it. Okay, you only about 20%. Okay, so try to make a good presentation and try to have a good demo. And I believe you already had the website and the GitHubs and the others. Okay, others will be your how can I say, about your attitude. Right? Okay, like Team 2, they are pretty aggressive. They spend a lot of time in the lab. So, yeah, I will give them some some plus scores. Okay, so, but today we are not going to have a break because the schedule is very tight. So you want to take a rest, you just go out, take a rest. All right? We don't have time to have a break today. And I try to finish the exam as soon as possible. And at the end, just as usual, we will have a photo together. Okay, so let's welcome Team 2. Kim Tu, you can come to the stage. Ah. 你要用你的吗？OK， 那
What?
No, already today, but
I said around 2 that it looks like chocolate. I didn't know that's soya.
That's chocolate.
Yeah, chocolate.
那你要先加入，
我有加了。
你加了。
I'm not the only one.
OK， 那我先允许，然后全部结束。好，那就分享。分享一下桌面。你这样不好做。拿个桌子在这边。
Can we make that bigger?
but I think also we should
Maybe after. Yeah.
already
这是饲料或者
I don't know to hide them.
饲料。
Oh no. Wait. Do we need it?
I think it's like
maybe you
changing
want
the layout.
Yeah,
Yeah. Wait. How?
but yeah, I don't know. Maybe you can use this one. No?
It's.
Well, you only got 20 minutes.
I mean, what should we do now?
No, you control.
Yeah,
Yeah, no. It's just the size. We're making that.
Okay, this is our project called Smart Irrigation Beyond Tradition, Agriculture 4.0. Let's see what's behind our project. Well, most farmers still rely on methods handed down through centuries and almost based exclusively on the empirical experience. So farmers touch the soil, observe the leaves, and even smell the air to know when to irrigate. But this traditional approach is no longer suitable for two main reasons. First of all, the demographic crisis, since the rural population is aging rapidly and there is not enough manual labor to manage kilometers of gates and canals. And secondly, the climate crisis, because we can no longer expect that the next year will follow the same seasonal pattern. In fact, climate faces extreme variability, swinging from torrential rains to bright and sharp sun. And because of climate troubles, those events have become unpredictable. Relying only on the calendar or on the physical touch of the soil means wasting water right before a storm, or on the contrary, leaving plants in a state of water stress during sudden heat waves. And our project wants to close this informational gap. Our goal is not just to automate a pump, but to transform irrigation from a reactive process to a proactive one. We want basically to shift from an experience-based culture to a data-driven agriculture. But what's the main difference? Well, a traditional system can only respond to what human sees now. Instead, our intelligent system can look towards the future. In fact, by integrating the local perception of physical sensor with the predictive power of cloud, our architecture can tell the soil now is dry, but in 3 hours there will be a storm, so I will not waste water now. In summary, our vision wants to reduce the water scarcity and to solve the problem of climate unpredictability by also reducing the workload for the farmers.
Then I will start with the overview of the system architecture, which you can see here. I will mainly talk about the components, and I will talk about the AWS cloud. Well, first of all, to the used hardware, we use many different components. Our brain here is our ESP32 controller. Then we also use motor driver, which is providing electricity and logic to the pump. They are all connected together, so the ESP can control via the motor driver the pump. And we also got the soil moisture sensor to see how dry or how wet the soil is, and LCD display to see like the different sensor data, soil moisture, temperature, etc. We have the LTR 390 degree sensor, a water flow sensor, so we can check how much water the pump provides, and a temperature and humidity sensor. Then I will come to the next part to how I finalized the hardware. The first step was, first of all, to create a circuit diagram for all my components. I used the software Fritzing for it, as you can see here. See here that this was one of the prototypes I did in the software. The second step was to connect the components to each other and solder it on the perf board, and also the first testing. As you can see, I did it here in the workshop. It took quite a long time to solder all the cables together, but in the end I achieved everything. And the third step was to creating a box where we can put all the components in it. We used a 3D printer for that. But first of all, I needed to create a 3D model of the box. I used the software TinkerCAD for that. It's just free software you can use in your browser. And as you can see here, I separated the components into like the front side and also the other part of the box, where you can see here also all the components we're gonna put in it. The fourth step was then to print the box in the 3D printer. And the fifth step was placing the hardware then into the box and the final testing, which when the final tests arrived, we will also test like the AWS, etc. We saw some problems. The main problem here was that the ESP we used had a non-functional wireless and Bluetooth, so we needed to have another board connecting to the ESP. So we had then two ESPs working together, and we connected it via cable so they can transfer data to each other. And yes.
Okay, then I'm going to introduce all the AWS service we implement in this project. So as you can see, I mainly use 6 services. So first, IoT core for connected to ESP32, then the Lambda to run the watering precision logic, and also the event bridge. I can schedule daily watering checks, and for the database, I use like S3 and DynamoDB for different use case, and also for the IAM for control the permissions. So the first is IoT core. It's the most important part, so we can connect from AWS to the ESP32. So for the messaging rule, you can listen to ESP32, and also when you read the data from the ESP32, you can push the incoming data to those different services, for example, like Lambda to calculate the rules, and also different database. And for the device shuttle, it's like a clone of our device. We can store the states of the data even when the AWS is not connected with the ESP32. And the Lambda. So first, we need to like calculate the decision on the Lambda. So I set the simple rule: if the moisture sensor is like smaller than 40% and the UV index smaller than 8%, it will trigger the watering decision. And of course, it could be more complex and also the garden shadow update. And you can call after the watering command is confirmed to keep the state accurate. And also for the event bridge, as I say, I can schedule a daily watering. So I set it will trigger every day at 7 in the morning. It could be any time in the day. I just set it's just an example. That's how I use the event bridge. And for the database, I use DynamoDB and S3. For the DynamoDB is for structural query layers, and its use case for recent data is in JSON format, so it's easy to read and to train and analyze. And for S3, basically it store raw data, so it's hard to analyze, but it's good for long-term backup.
Okay, so for a short conclusion to our project, we successfully developed a smart irrigation system that demonstrates how IoT and cloud technology can support modern agriculture. And the most important achievement of our project is not a single technology, but the successful integration of sensing, communication, cloud-based decision-making, and automated actuation into one complete IoT workflow. By connecting these components together, the system can monitor environment conditions, make irrigation decisions automatically, and reduce the need for manual iteration. And this helps improve water use efficiency and provides a foundation for more intelligent and sustainable agricultural systems. So this project serves as a foundation for future smart agriculture applications by integrating weather forecasting, AI-driven prediction, and mobile platforms. And the system could evolve into a more intelligent, scalable, and sustainable irrigation solution. Okay, so thank you for your attention.
And then I really going to do a demo, and let me set up really quick, and I hope it works.
Can you?
What's the view? What's the output?
You have that.
OK，你可以再重开一次。
把它从
对。Yeah, so you can microphone.
Yeah, so now the system is connected to IoT core and also subscribe to a topic. And now I can read all the sensor data in real time. So look at the time. You read the data in after 5 seconds. So we got all the sensors data like temperature, humidity, moisture sensor, UV index, flow rate,
Yeah, the current moisture sensor, it's like 0 because currently the sensor is in the air and the air means 0, while water means 100%. These are the two maximums, and like minimum and maximum. Yeah. And the UV index is also the 0. This means, I mean, there's no sunlight currently. The lux row here, this is the light coming from the artificial lighting we have here. This is just like not important for our project, this value. Oh, yeah. I don't know, I think that's the output, that's the... But we need something here on the output.
Then I'm going to like simulate a scenario to trigger the watering.
Let's see if it still works.
So here I set the watering duration at 3 seconds. Let's see if it works. Oh, it doesn't. Okay, I'm thinking the watering function now, so. And for lambda, those were those two functions I mentioned. One's for watering decision, and one is to update the state. And also, this one even a set like a schedule daily watering on 7 in the morning, and unlucky the watering is not function. So maybe we demo the website first.
Can you see the moisture? The moisture.
Okay. The website is pretty intuitive, and visually it can also catch the attention of people like simple farmers that never have any experience with this type of technology like cloud. And it's made by one page, which is the home, with our logo, Smart Irrigation, and it addresses the problem that farmers can face during their work, and the basic idea that we can propose to them. And if they are interested, they can also click this button that brings them to a page for our product with more information in details about our project. So we also briefly explain what's behind, so the logic behind our project. And in addition, there is a page that instead is about the team behind this project. So if they're interested in us, they can also contact. There is, in fact, this button, Contact Us, that redirects the user to this form where the user can put in personal information for being contacted in case he finds the project interesting. And that's it.
let me try it out again.
Yeah, what if I first be in the okay.
Did you unplug it?
Yeah, I'll be a report. Is the code correct?
Yes.
I think you only one thing is that it's better to introduce your GitHub without
Yeah.
you don't want to duplicate your secret.
40 seconds. Okay, so this is our GitHub, but yeah, we only have 30 seconds. And we introduce our object here and features and our system architecture, like hardware and software connection here. And our prototype picture here, and also some description for our hardware and software, and AWS service here. Yeah. And also, yeah, like this.
How about a file?
File.
Code file. So
Okay.
people can follow your instruction to duplicate your work.
Yeah. Actually, we put our image and presentation slides here right now, but our
Yeah,
coding still needs something to revise, so we will upload tonight.
Okay, I understand. Okay, anyway, thank you to the team too for the great demo. But they do have they have done a great job. But as you can see, they still have some shortage because, they have there's some trouble with their demonstration, but I think they should grab the time to focus on the web introduction and the GitHub introduction. Okay, but obviously, their GitHub does not provide sufficient information for user to know their technology. Okay. 知道为什么？就是说他们其实不用那么紧张，在 demo 做不好就。你应该是把你的专题介绍好，然后把你 GitHub 完整的跟大家讲，这比较重要。知道为什么？demo 如果有出差错，不要那么慌张。Okay, so team 5, please.
I lost words.
Tiếng Anh nhìn kiểu gì?
Okay.
Nhìn tiếp bên này.
Okay, 20 minutes.
Wait a minute.
Wait a minute.
I cannot wait.
Ui, chạy
You
rồi,
are
chạy
still
rồi.
very
Chạy
happy.
rồi. Lâu rồi.
Đúng rồi, còn cái nội dung lại nữa chứ, xem nó bị chèn lâu ấy. Thôi, em cùng trực tiếp luôn.
Vâng. Đinh đinh đinh. Oh my god. Okay. Okay. Tìm trước.
Tấn, em bên Tấn cho anh.
Okay.
Hello everyone. Our groups today we're gonna present about our smart cushions. So let me introduce you guys about our team first. So we got Phương for the hardware and edge engineer. Nam is for fog and hardware integrations. T is for cloud and dashboard developer, and me just for real-time dashboard architect. Wait. So I want you guys to think about your day. So when you wake up, you sit up breakfast. When commutes, you also commute sittings, 8 hours at desk, also sittings, dinner sittings, screen time before bed, sitting again. We're in the most sitting generations in human history, and for the most part, nobody is monitoring that doing to our bodies. So fitness tracker counts your steps, sleep tracks your night, but the 8 hours you spent in a chair, that's the blind spot. So that's the gap the smart cushion was built to close. So introduce you guys about our products, improving your sitting with Capybara companions. So transform your sitting habits with our IoT smart cushions, meet your AI health companions, detects posture in real time, and embark on a gamified journey to spinal wellness. So a journey through the problems. So the first up, the silent killers. So what does it mean? It's the result of cumulative buildings of sitting wrong posture over time. And then what happens? There's a survey was done, around 3.2 million annual deaths relate to physical inactivity and poor sitting postures. So what does our solution brings? The smart cushion proactively tracks your posture to break the bad habits patterns and also lower the long-term health risk. Next up, spinal misalignments. So with what happens if you sit for a long period of time with the wrong posture? For example, your spine might tilt 38 degrees and it permanently damages you. And not only that, you also have to waste time and also money to fix your back or your neck. So what is our solution brings? It detects these bad sitting angles in real time, alerting you to adjust and prevent spinal compressions. And last but not least, rising disease trends. So a survey was conducted around 2020. That was around 600 million cases have a lower back pain, and it was projected around 30 years later, around 800 million. So what does this do to our solutions? So the smart cushion helps you to maintain spinal health continuously, prevent you from becoming a part of this growing statistics. So let's check our solutions. So our technology is more than just hardware. It's a comprehensive ecosystem designed to improve your health. And we didn't build just a cushion. So it's gonna be your companion. And let me show you what's inside. So first up is our cushion right here. Very simple, only 3-color design for now. With blue and gray color. If you don't like the color, I mean, you can send us the design, we will design for you. So first up, let's talk about our features. So 5 posture recognitions. So your cushion knows exactly how you're sitting, not roughly, not approximately, exactly. So 9 pressure sensor, 5 posture types, real time, every second. So you don't have to think about your posture anymore. The smart cushion do it for you. Next up is embedded fog computing. So here's something the smart device get wrong. It sends the data to the cloud and then react. That's delayed. It costs you. We process everything right, the cushion, so instantly, locally, and privately. So no lag, no one watching your data, just pure immediate response. Real-time ad feedbacks. So the moment you start slouching, your phone knows not 5 minutes later, right now. And over time, you can see yourself getting better. Your posture score improving weeks by weeks. That's not just feedbacks, that's the progress you can be proud of. And then cloud integrations, every sitting sessions, every corrections, every movement is all saved. Built on AWS, the same infrastructure that powered Netflix and NASA. Your health history lived in the clouds and always with you on any device. And then smart vibrations. You're in class, for example, you're in class, you can't look at your phone, you can't look at your website, your posture is going to be bad and you don't even know it. So smart cushions just tap you quietly, gently, just for you. And it respects your focus while protecting your spine. And last but not least is the Capybara Dial Journeys. So this is, maybe everyone loves it, but meet your Capybara companion. If you sit well, your companion will be happy, driving, full of energy. And you slouch too long, your capybara will be suffered. So we turn spinal health into something that you actually care about, because the best habit is the one you enjoy keeping. So let's see how it's all connected together. So how is this gonna look? Let me take you on a journey of our architecture. So here's our model architecture. So it starts here, our smart cushion. Let's begin our smart cushions. The moment you sit, the nine sensors wakes up and start reading your body. Every shift, every slouch, every micro movement captured instantly as analog signals. And then we're moving on to the Edge MCU. So those signals travel to a tiny powerful chips, the ESP32. So think of it as a first brain. It cleans up the raw data and package it neatly, ready to be understood. And if your posture is already bad, it's fired the haptic alert and before anything can reach the cloud. And that's how fast it is. And then we're moving on to the AI, the fog node, which is here's where all the intelligence lives. The fog node, our AI brain, receive that data and start classifying exactly which posture you're in. So locally on device, no internet required. So this is why smart cushions never lagged. The thinkings happen right here as close to you. So the fog node, if it classified your posture and it is wrong, it will send back the haptic alert to the edge CPU to rings that you are seeing wrong. And then moving on to the AWS IoT Core and Lambda. So one is classified, it's going through the AWS IoT Core, and then your data travels secure to the cloud through AWS IoT Core, encrypted with TLS. So the same security standard that was used by banks. So Lambda functions process in the background, storing in your sessions, calculating your trends, and powering everything you see on the screen. And last but not least, our live dashboard. So everything lands it here. Your live dashboards, your real-time posture, session history, your capybara companion reacting how well you're sitting. So from a pressure on the cushions to a live pictures of your spinal health in milliseconds. So to sum up, 5 components, 1 seamless pipelines from sensor to screen. And I'm just going to talk to you guys about briefly the cloud servers. So we use AWS IoT Core to our data flowing from the fog nodes to our clouds. It's very encrypted, verified, and routed to the right place. It's a very secure gate. And then we have our cloud formation, just for act as a builder. It built the entire cloud with codes. As you can see here. Amazon Cloud Watch is just for, it acts as a guardian and is monitoring everything, collects system performance and runtime on metrics. And then our Amazon Dynamo DB is all for storing our project's entity, is acting as our memories. And our AWS Lambda is just for classifying and executing business logic on demands. And last but not least is our API gateways. So it's for delivering to your screens, REST for your history and data, and WebSocket is also for live updates to the moment your posture changes it also your dashboard will show it. So basically. So does anyone ready for our demos?
Okay, so I will go to the line demo for to see how all the work here. So this is you see. Okay, so I will show you this is the outer dashboard we are building here. Before we can see the dashboard.
Không biết dài. Được sao? Bây giờ cái tiếng nào đi.
It's okay, it's okay. Okay, before you can see the dashboard, this one is our product here. You can see the mask cushion here with all the X inside. And what we will use the X when we sit, we use the X to send the data into the box. And right now you just see the computer here. This is like at the box, no? To processing all the data, send back to the sensor to remind the user if they have the wrong posture. And meanwhile it will send the data into the cloud and do some analytics and provide more insight for the user and provide back to the dashboard. So you can see the dashboard here. This is the live status. So what happens if I sit on the chair here? When I sit on the chair, it will immediately send the data to the Foxtrot to do processing and show in the live startup here. Now that I will show you how we have a file posture, right? So this is the sitting upright. Wait for a moment. Okay, let's do again. So this is the sitting upright. This means this is the correct posture for your health. And then what if I check in the live status dashboard here, if you have the heat map, alert status, count, and show you what is the current posture. Right now, if I normally when I walk, I stretch, I will lean forward to do the typing like this on the computer. So it will show that I have a wrong posture with the leaning forward. And it will start at alert and increase. You see what in this work here is mean the posture score will decrease, and it will tell you need to improve your health. And in the office we will have a lot of different postures. Sometimes we do like this to do thinking and do walking like this. This is the leaning right. It's not good for your spine as well. And I will do like this. I sit like this here to do the work. This will show the leaning right down left. And for the last posture, sometimes the task is so boring and you do the work like you work lie in the sofa. I will sit like this to do the work. It's like you watch Netflix and chill. And this one for the overtime, it will cause the pain in your shoulder, the neck, and also you have the back pain. So it will show that the leaning backward. And in here we have a vibration to change. It will generally remind you have the wrong posture. You need to correct it immediately. It will vibrate here to tell you. And then when I sit upright again, yes, upright again, and you see this one, it will improve. It means that you correct your health, your posture immediately. So this is how the lifestyle was showing. Next we will move to the top tab. So in this tab here, the pop-up question that the lifestyle search tells us how am I sitting right now. For the cost, it will tell you how am I doing, how I can improve my habit a little bit day by day. So you see in the first row, it will be provide you all the summary of the key information. You have the total sitting time hour per day, full posture time, alert count, and the full posture score. And in the second row, it will provide you the weekly progression detail. You compare day by day, so you can know what is your habit day by day and week by week. And we have the real-time starter as well, because right now I sit at leaning leg, so that's why it shows the leg. If I sit like the backward like this, it will show the leaning backward. And the last one, it will have the AI advisor to provide you action to improve it. And you can see we have one philosophy to design when we look at the user here. On the tab here, we have one design logic form on the first row. On where will be the summary, provide the key information for the user, so you can know which is the action right now you should take. And you can see we use the color because the audience we have the young, the elderly people. Some people they really boring when you look at the data, you don't know what to do. So we use the color light red to show that this is not good. So you need to take action to improve it immediately. The yellow is mean totally you are improving, and the green color is mean you are doing good, and you need to keep doing it. This is a good job. So that's why, and one more, because when you look at the data, you will feel boring. So that's why we have some of the working here. The 33 is mean it's not good, so you need to do this working. We have the working, so make the user more friendly with our system. And the last one, we go to the inside. Next, we go to the My Insight. So this one, you see, everything we do the same. The first row, we always do the summarize, provide the key information for the user. Secondly, we will have the write down the weekly posture pattern. This page answer that how I build the sitting habit time by time, day by day, so I can know which one is the best, the worst, so I can improve it. And right now, in the weekly posture, I build for every day. If I sitting upright, it will show that the key posture is upright. Let's say if I lean backward so much, it will show the key posture is backward. So I need to know my sitting habit is not good for my backbend. I need to improve it. And the last, we will break down the posture for time by time of the day, so you can know and monitor. It depends on your workload and routine. And we also have the AI expressor to recommend what you should need to do to improve it. So for the My Insight here to help you to understand how the habit you build over time, so you can know which one you need to have the key focus and improve. And for the last is the My Section. This one is a section for something like me. I don't believe on the data. Sometimes I want to understand the detail, how the data report in the detail. So the My Section will again in the top row provide the key information for you in the advance. And for the in here it will record for every section, so you can know that in every detail how about your habit over time. You can track and understand, analyze, and improve it. So this is on the main core 3 tasks. The My Life will provide answer the question, what's happened right now. For the coach, it will represent how we do it, daily and weekly monitoring. And for the My Insight, we answer what habit I do over and over time. And the My Section to track and understand what really happened to my body and my habits. And the next one, we not not focus here today, but we have some of the feature like my data. We got here, we have something like the game. You can see, you collect the game together, and you have the My Collection and My Passport. And in, let's see, take a look. You will have something like you think this one is like again. When you interact with the app and you improve it a little bit, it will send you a badge like a reward. So it helps you to be fun, engaged, and purposely to motivate you to improve your fast sitting habits over time. And in the long term, we will scale this one to make sure that the user will more long-term engage and with our ecosystem. You can see, and maybe you got on the bus here, you can send to the line to your friend to share that you have the achievement, you already improve your health. Okay, so this is for the end for our demo. But you see that because here right now I only have one function here and one laptop for front knob. But for example, everyone in the class, each of you have one of the math function to sitting on and improve, and how we can scale it. Now I'm back to the architecture. You see, this is the architecture happen right now. Let's say I have 100 cushions. So how the system can. So for the match cushion, it's very simple, straightforward. If I have 100 match cushions, it will have 100 edge to perform collect the data randomly for each person. And then right now for the first knob, the local computer cannot processing big data like that. So we need a more AI server have the capable to handle the big data, processing all the data in parallelly, and provide immediately response to each of the user here, and also able to send the big data to the cloud for processing. And the last one, just one simple. And for the cloud, we can scale. But for the cost here, I just say that for the cost, of course, we spend for the AI server. But for the cloud, you remember that the more data you use with AWS, you get cheaper the cost you save. This is the economy of scale, so we can balance the cost. So I think summary, This is our GitHub. You start the work. Now want to explain? Yeah. We store all the data, the hardware design, the smart function on the X side in our GitHub here with all the code, how to collect the data from the sensor, send to the port, and the port back to the sensor and send to the dashboard. And this is how architecture we design. And for the last one is Amazon. You can see if you want to take a look. In the Amazon design we built, as we mentioned earlier, we will have a lot of the collection data. This one is the section data, every detail I show you in the migration class here. We collect every time and we store that and we do some analysis to provide more insight for the user. So that's end for our presentation.
Okay, thank you.
Thank you.
Well done. Well, anyway, both presentation and the demo are great. So I think you are ready for start competition already.
If you are interested, but sorry, we're not open for resale yet.
Okay, let's see.
How we go.
配合那个仪式的话，就是我看有点太多。
你要桌子吗？
你要桌子？好。
Okay, so
看你喜欢吃的什么？先放。
开始计时。
OK。
还是等一下吧 ，demo。
Alright, good morning everybody. Like today I'm excited to present you the final project. This is the smart lock system. So at first it looks like a small things, right? Where is the real one? The demo. It's just it's there. You can see it's on the left there. So actually this is the prototype. We combine three important ideas. So have the Edge AI, physical unlocking, crowd evidence. This system can recognize a person, unlock the door, and record the event in the crowd. So this is not just a lock. This is the door that can see, can decide, can act, and remember. Guys, I have something special for you. This is the durian from Thailand. I brought it. For real. Is it cool? Durian baby. Yes, I lied. This is fake, I lied. So how are you gonna believe in the future, right? This is the problem. Right now, every house, they use a key, they use a card, and they use a lot of things, but nothing can know the real things, right? So we have the problem on this one. So I'm gonna ask you one simple question. What if a dog could know who is standing in front of it? This is gonna be great, right? So our answer is the smart access system using face recognized, edge computing, and crowd locking. Alright, for the final projects, we focus on 4 objectives. First, smart user verification. The system should recognize and authorize user in a simple and natural way. So the second, zero damage installations. The prototype should demonstrate the lock mechanism without damaging the original door. Third, crowd security locking. The system should have save important access event and introduce evidence. Fourth, last but not least, student budget, which is we got a little money, but we need to make a big project. I'm so impressed with that group already. So we want to build a working prototype using CFiot hardware. So our goal was very clear right now that make access fast at the door and traceable in the crowd. All right. Now let's look at the intelligence inside the system. Our main software stack is Python 3 and OpenCV. Edge computing and Raspberry Pi process the camera input locally. It handles face recognitions and local decision process. For crowd integration, the system connects to crowd service to store logs and introduce photos. The key design choice is the data doesn't decide who enter, the edge does. This is the keywords, guys, because most of the objects in the world right now, the key unlock things, they use in the cloud, which is make it a lot more slower. Why? So this one gonna make the door can be respond very fast. And last time we have the problem that our things not match with this clause, right? So we have to go back and we learn and we improve more what to make it match to the cost. So this slide shows how our project connect to the class. In IoT, the goal is not only connect device. The goal is to collect data, use data, create actions. Our system follow the idea layer by layer, as you can see here. At the physical layer, we have the camera, Raspberry, and model lock. At the network layer, we use Wi-Fi, TCP, and cloud connection. At the edge of fog layer, we run local face recognition and make the unlock decisions. At the cloud layer, we store security log and intruder image. And last but not least, also at the application layer, we provide a website, dashboard, GitHub, and document. So the message is very simple here. Edge gives us speed. Cloud gives us memories. Okay, this is the main architecture of our system. We have two pages here. The first page, we show that on the left, this is the camera capture the image and Raspberry Pi receive the input. Then the system performs local processing and prepare the actual actions signals. On the right, we have the recognize logic. The system detects the face, improve the input quality, and verifies the user. So if the user is recognized in the system already, they're gonna send the signals back to the lock system. Then the model can unlock the door. This architecture is important because it is separate two jobs clearly here. This edge handles real-time access, cloud handles long-term record. That makes the system fast and more practical. Okay, so this slide shows the hardware side. We use a Raspberry Pi 02 watt and UL 2003, which is a very hard number, I don't know, and the step motor. The Raspberry Pi send the signal through the GPIO on the top here. And the motor driver receive those signals and control the separate motor. We also use an external power supply for the motor because the Raspberry Pi shouldn't power the motor directly. This is the physical part of our project. The AI decisions become a real action. The system doesn't only recognize, it's also unlocked for them. Here we have the famous guys on the left there. So now let's move to the cloud. When the system detects an access event, it uploads data to cloud storage, keep intruder image. The database table storage the security event log. Each record can include timestamps, detection status, image data, and update time. This makes the system traceable. For security, stopping an unauthorized user is important. With cloud locking, every important access attempt becomes a record. So the door does not only react, it can remember on the cloud also. Okay, for the final testing, this is very important because we're gonna show you how accuracy of this one. After improvement, we test the system already. For authorized recognition, we got like 19 out of 20 successful tests. And for unknown user detections, we got 20 out of 20, which is 100%. And the average recognition times was around 1.3 to 4 seconds. And the model response time was around 8 seconds. And the crowd upload time was around 2.4 to 3 seconds. And the complete whole process here is around 8 to 15 seconds. The results show that the system can complete a fully IoT cycle, like sense, decide, act, record, review. But at the same time, we learned what we learned from here, the number. We just not throw the number here on the PPT. What we learned here is like can still change depending on light, right? Because sometimes the cameras cannot detect the face by the lighting, so we can improve that things also. And the training image and the network quality, sometimes the Wi-Fi is not that good, so we can improve something. What we learned from here, number. All right, this is the website we're gonna show you later, so let's skip this one first, okay? I'm gonna show the video.
要 show video
可以 Alright. So this is how it works. The first one, we're gonna make the door open. So this is the back door. And this one is uploading to the cloud. So as I say, it can remember everyone. So we're gonna show you the demo later. Okay, let's show the demo. It's become global now, guys. Do you want any volunteer? Okay. We need a volunteer here. We're gonna try for you. We just need one photos of you. Okay, come. So while we're waiting, in the demo we focus on 3 scenarios. The first one is authorized users, is recognized. So these guys have not recognized when he walked to the door cannot open for him because it's unrecognized. So what we're doing here, we try to make the door recognize him and put in the crowd.
You better not like classify me as like a non-human. That's right. That's right.
我现在重新连接一下。
Why Michael Jackson? Yes. You love the movie?
I haven't seen that. Yes. I have English.
Subtitles.
Previously used a hack.
These are twice as much. Could have come up with they want how many layers it is already how to 16 weeks. And 1 week is 7 days, so 16 times 7. What?
Okay.